All right, welcome everybody. Here, this will be a very nice lesson with a very nice question. Here, we want to find the equation of a tangent line to a curve. So let's take a look. Here it's saying, given f of x is equal to 3x to the 3 plus 5x, find the equation of the tangent line of f. So for this f of x at the point where x equals 2. All right. First, we need to visually understand what is going on in this question, right? Here, let's say they don't give you a picture of the graph, but I'll give it to you anyway, just so we have a visual understanding. It's saying if we have this function f of x equals 3x cubed plus 5x, what does this picture look like? It should look something like this, right? This is f of x equals 3x cubed plus 5x. If you want to check it out on Desmos, it should be very close to something like this. Now, what is this question saying? It's saying, find the equation of the tangent line of f at the point where x equals 2. So here, if we have this graph over here, and this is x equals 2, it's saying at this point, let's create a tangent line, right? So here, this is a tangent line. Okay, so we have a tangent line. What is this question saying? It's saying, what is the equation of this line? And when we have an equation of a line, it should be represented as some y equals mx plus b. Yeah. So then how do we do it? How would we find the equation of this line? What do we need to find the equation of any line? So if I have any line, like this, whatever the case may be, what do we need? We need two things. One, an x value and a y value. And when we mean, what do we mean by the x value and the y value? That here, for this line, right, there's that point of intersection with this graph, right? What is the x coordinate for this point? What is the y coordinate for this point? Notice we have the x coordinate, it's 2. Well then, how do you find that y coordinate, right? So that's one thing we need. Second thing we need is a slope, right? Because if we have some y equals mx plus b, we need a point and we need a slope, okay? And what is the equation of, what is the point slope formula? Here, it should be y equals m times x minus x sub 1 plus y sub 1. Okay? So notice that here, my x sub 1 and my y sub 1, this is represented by this point here, right? This is my x sub 1, this is my y sub 1. So we need a point, and we also need the slope of this line, right? And that slope of this line is represented by m, okay? And the y and the x will be part of the equation, okay? So notice, yeah, that's what we need. So the first part, we have our point of x. We know that this value here is 2. The next question I have for you is, if I said, hey, no, this is not the question I want, this one. If I asked you, hey, what's the x and y value of this point, how would we find that? Well, we know the x value. How would you find the y value? Pause the video and think about it. If you're given this function, how do you find the given y value? All we need to do is plug in 2 into this function, into the original f of x. So 1, let's just find the point. If I have f of x equals 3x cubed plus 5x, then what is f of 2? When I have 2, what is this y value here? So it's just 3 times 2 cubed plus 5 times 2. 2 cubed is 8, so 3 times 8 plus 10, which is 24 plus 10, which is 34. Oh, sorry, my camera angle is very bad. Sorry. So notice that when we plug in 2 here, this value of 34 represents our y coordinate here. So when we go back to this original part of the question, our x sub 1 is 2, our y sub 1 is 34. Okay, so far so good. Now, what do we need to find? We need to find the slope of this line, because this line has a slope, right? How would we find the slope of this line? So here, this is the next question I asked. If I said, hey, what's the slope of this line at this point? How would we find that? Okay. Pause the video and think about it. What would we do? Okay. Well, we've been learning that what does the derivative of a function calculate? It calculates the slope at any given point. So, if we know the derivative of f, if I know that f of x is equal to 3x cubed plus 5x, if we find its derivative, okay, well, what's the derivative? What's f prime of x? This is equal to 9x squared plus 5. Now, if I plug in 2 into its derivative, it will tell me the slope of this tangent line at 2. Please, those words are golden, because that's a hard concept to learn or understand when you're first learning calculus. When we plug in 2 into the derivative, we are finding the slope of this tangent line at 2. For example, let's say this is -3, and the slope and this tangent line is here. If I plug in -3 into the derivative, I'm finding the slope of that tangent line at -3. Okay, so here we just have to plug in 2 into the derivative. So this just becomes 9 times 2 squared plus 5, which is 2 squared is 4, so 9 times 4 plus 5, which is 36 plus 5, which is 41. So the slope of this line is rising 41, or 41 units per 1 unit to the right, or 41 units down. I'm sorry, not at each, it's not constant, my bad. At this, the rate of change at this point is increasing at 41. Okay. Okay, so now we found this 41, which will be represented as our m. So all we need to do is just plug in these values into our point slope formula, because what this point slope formula does is it says, hey, you give me a point, you give me a slope, and I will create the equation of this line, because the equation of any line will be represented as y equals mx plus b. So then here we go. It's just y equals m, which is 41, times x minus x sub 1 is 2 plus 34. So then y equals 41x minus 42 plus 34. So y equals 41x minus 8. And that is the equation of whoa, pause. I made a mistake. Pause. What am I doing here? 41 times x is 41x, but 41 times minus 2 is not 42. This should be 41x minus 82 plus 34. So y equals 41x. Negative 82 plus 34 will be 58. 58, yeah. No, 48, I'm sorry. This will be negative 48. Okay. And this equation here represents the equation of this tangent line for this function 3x cubed plus 5x at x equals 2. All right. I hope this helped. Enjoy.